Hi everyone. Today we're going over a few performance measures for machine learning. You may be wondering, why do you have to use different performance measures? Well, think about this example. You're training a machine learning model that is supposed to detect skin cancer, but your training data set only has one positive image and 99 negative images. As a result, your machine learning model just trains to mark everything as negative. So when it shows its accuracy after it's done training, the accuracy is still 99%, but you know that the model is not very good because it just predicts everything as negative. It's not actually trying to guess correctly. In that case, you would have to use a different performance metric to show the true measure of how good the model is. Selecting the proper performance metric is very important as it is the main way to communicate the findings of your research. So, some ways that you can communicate the findings of your research are through the confusion matrix, which can help you measure the recall, precision, specificity, accuracy, AUC-ROC curve, and sensitivity. And you can use the AUC-ROC curve itself. So, first, let's look into the confusion matrix. So, the confusion matrix is divided into four boxes. The top left box shows the true positives, which is you predicted the value was positive and it actually was positive. The top right box shows the false positives, which is where you predicted it was positive, but it was actually negative. This is known as a type 1 error. The bottom left box shows the false negatives, which is where you predicted it was negative, but it was actually positive. And the bottom right box shows the true negatives, which is where you predicted it was negative and it was actually negative. So these values can help you calculate some more performance metrics like recall, precision, and so on. So let's look at how you can calculate those. You can calculate recall by taking the rate of true positives over the rate of true positives plus false negatives. You can calculate precision, which is also known as sensitivity, by calculating true positives over true positives plus false positives. You can calculate specificity by taking true negatives over true negatives plus false positives. And you can calculate accuracy by taking the total number of correct predictions over all of the data. You can also look at the AUC-ROC curve, which is created using the number of false positives as the x-axis values and the number of true positives as the y-axis values, and they all range between 0 and 1. So you can also use the AUC-ROC curve to interpret your data as well. And this is created using the help of a confusion matrix because you can see that the x-axis represents the number of false positives and the y-axis represents the number of true positives. So you can look at the values along the curve to interpret the data. For example, the lower the value is on the x-axis, like the bottom value over there, that means lower false positives and higher true negatives. And if you look at values that are higher on the y-axis, that means higher true positives and lower false negatives. So if we go back to the example that I gave at the beginning of the video, you would see that accuracy actually wouldn't be a very good measure of the model's performance. In my opinion, I think precision would be a much better measure of the model's performance. But you can also think to yourself what you think would be a better measure of the model's performance than accuracy. And you have to keep thinking when you're communicating your data to other people so you can accurately show what the precision of your machine learning model is. As always, if you have any questions, you can leave a comment below or email contact@ainspired.org. Thank you so much.